Hi everyone, this is Miss Oi here. We're going to start circular function. Let's look at the very first lesson, measuring angles in degree and radians. So the angle in radians swept over in one revolutions of a circle is 2 pi radian, which is equal to 360 degrees. So therefore pi radian is 180 degree and 1 radian is 180 over pi degree, or 1 degree is equal to pi over 180 radian. So the unit for radian is C. Can you see a little c here? And a degree is just that 0 here. All right, so what is 1 radian? 1 radian is basically the angle subtended at the center of the unit circle by an arc length of 1 unit. That angle that's subtended at the center, it is called 1 radian. And because 1 full cycle is 2 pi unit, because 2 pi r, that is the circumference, so therefore give us 2 pi unit. 2 pi unit is equal to 2 pi radian, which is 360 degree, and that's how we got pi radian is 180 degree. So to convert degrees to radian, you multiply by pi over 180. And likewise, to convert radians to degree, you multiply by 180 over pi. So there's this little diagram for you to remember. All right, converting degree to radian using CAS, very simple. Firstly, if you want to convert degree to radian, first off, make sure that this is in radian. And then what you do is that you go to the trig tab, 60 degree. Can you see there's a degree sign here? So 60 degree. Make sure that you have a degree symbol and then you press enter. And then you're going to get pi with 3. The calculator return pi 3. 75 degree, press enter. The answer will be 5 pi on 12. From radian to degree, make sure that that is in degree mode because you want to convert radian to degree. And again, you go to trig, look for the R. That R is only for the calculus symbol for radian. The proper notation, or rather unit for radian, is actually C. When you copy in your work, please make sure don't put R but rather C. But in our calculator here, that R is radian. So pi over 4 radian. Press enter. They'll give you into degrees. So that's 45 degrees. So 5 pi on 6. Again, make sure that you have R here. And press enter. You have 150 degrees. Example 1, convert the following degrees into radians. Negative 225 degree. If I want to convert to radian, I need to multiply by pi over 180. So that would give you negative 5 pi over 4 radian. Convert the following radian to degree. If I want to convert 11.6 radian to degree, I multiply that by 180 over pi and simplify that pi and pi can cancel. 16 going to 180, 30, so 30 times 11, which give you 330 degree. So I'd like you to pause the video and work on question 1, ACE, 2 ACE, 3 ACE, 4 ACE. You probably need to take 5 minutes of your time. Question 3 and 4, you need to use your CAS. Question 1 and 2, you go without CAS. To the next slide. So the unit circle has 4 quadrants. Let's look at each coordinates. The boundary point 1, 0, 0, 1, negative 1, 0, 0, negative 1. So we have 4 quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you need to know the range of angle values in each quadrants. All angles are basically measured anti-clockwise from the positive x-axis, that's positive x. And of course, negative means that it is measured clockwise. So let's look at the boundary angles. 0 at this point, pi and 2, pi, 3 pi and 2. 3 pi and 2 is 270 degree. So quadrant 1 we from 0 to pi and 2. Quadrant 2 is from pi and 2 to pi. Quadrant 3 is pi to 3 pi and 2. And then quadrant 4 is 3 pi and 2 to 2 pi. And the specific angles that we talk about, 0 pi and 2, 2 pi, 3 pi and 2, and 2 pi, they are called the boundary angles as they lie between quadrants. Right. Next, let's look at the coordinates. So this unit circle can be written as a function of x and y. The relations, the coordinate point is xy, right? So revisions, a little bit of revision on SOHCAHTOA, the trig ratio. Sine theta is opposite over hypotenuse. If this is theta, opposite over hypotenuse will give you sine theta. Cosine theta is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's look at this x over 1. X over 1 will give us cos of theta, and then y over 1 will give us sine of theta. So therefore, instead of writing p as a coordinate of x and y, we can write as cos theta and sine theta. So your x coordinate is cos theta, your y coordinate now is sine of theta. That is cos theta. All right. So we can now look at the trig ratios of. Okay, let's look at another important formula. If a tangent to the unit circle at A is drawn, then the y coordinate at C, that's the y coordinate at point C, which is the point of intersection of the extension of this point OP. Extend this until it meets this tangent line. That distance from point A to C is called tangent theta. So by using the concept of similar triangle, so let's draw that out. So we have cos theta, sine theta here. And we got this distance as tangent theta. And here to here is 1. Because from here to here, that's the radius. So the big circle is tangent theta over 1. It's the same as the ratio, that's y over x, the same as sine theta over cos theta. Because this small triangle and the big triangle, they are similar triangle. So which gives us tangent theta is equal to sine theta over cos theta. So from now on, we can say tangent theta is sine theta over cos theta. So you add pi to the angle, it does not change the line OP. So in other words, tangent of pi plus theta is the same as tangent theta. The other important point, if we look at the tangent theta, notice that when cos theta equal to 0, what will happen to the tangent theta? Well, I can hear you guys saying that tangent theta will be undefined. That's correct. And we know that cos theta will be equal to 0 at pi over 2 and at 3 pi over 2. And of course, it doesn't just stop there, keep going. Can go around to the next cycle, which is 5 pi and 2. And of course, you can look at it in the negative directions. You get negative pi and 2, negative 3 pi and 2, and negative 5 pi and 2. So the domain of tangent theta is all the real number except plus minus pi and 2, plus minus 3 pi and 2, plus minus 5 and 2, and so on. All right, next slide, exact value of a circular functions. Very important in exam 1, make sure that you know this value well. Cos pi and 6, you need to know what's cos pi and 3, what is sine pi and 3, sine pi and 6, tangent pi and 6, and tangent pi and 3. Now, one method is using the special triangle. So let's look at this equilateral triangle. Let's look at the simplest that I can use will be 2, 2, and 2 here. So that if I were to divide these into 2 triangles, that will be 30 and 30 on one side. And that will become 1 and 1. So let's reduce to just look at one side. of that triangle, we have 30, 60, and 90 here. So the one that is across a 90 degree, that's 2, and that's 1, and that is root 3 using Pythagoras theorem. So I want you to take note that the one that is opposite 30 degree is the shortest distance, that's 1. So this is the 3 number that you got to remember, 1, 2, and root 3. Root 3 is about 1.7. So that's across 60, and the longest is 2 here, which is across 90 degree. So cosine of pi over 6, which is cosine of 30 degree, is adjacent over hypotenuse. So which give you root 3 on 2 here. And sine pi on 6, which is opposite over hypotenuse. Tangent pi on 6, which is opposite over adjacent. And cosine pi on 3, which is 60 degree, pi on 3 is a 60 degree. Cosine is adjacent, and hypotenuse is 2. Sine pi on 3, which is sine pi on 6, opposite is root 3, and hypotenuse is a. Tangent pi on 3, which is root 3 over 1, which is root 3. By the way, this one can be written as root 3 over 3 as well. You can rationalize root 3 by times root 3 times root 3 will be 3. Okay, so this will help you to remember the exact value. This special triangle will help you to remember. Now, if I were to put 30 in here, that will be my 60. Always remember the cross the 30, you immediately put 1. Hypotenuse will always be 2, and that will be root 3. That's the last one. So therefore, if I want to look at cos 30, adjacent over hypotenuse root 3 on 2. It doesn't matter where you put your 30, but wherever 30 across is always 1. All right, another special triangles that you probably helpful for you to find exact value is the isosceles triangle, right angle triangle. So 1, 1, so that will give you root 2 here. Cosine 45, which is pi on 4, of course, in terms of radian, it is 1 over root 2. Adjacent over hypotenuse, and we can rationalize to say root 2 on 2. Sine pi on 4 is the same, 1 on root 2, which is root 2 on 2. Tangent is 1 here. Method number 2, via table patterns. Some people like this method, but I personally prefer the one that's using the 2 special triangle. But I'll go through this anyway in case some of you are familiar with this method or prefer this method. So 0 degree, 30, 45, 60, and 90. If you're using this, make sure you write 0, 30, 45, 60, and 90. Or 0 radian, pi and 6 radian, pi and 4, pi and 3, and pi and 2. And then you got to start with sine, cos, and tangent. So you go root 0, square root 1, square root 2, square root 3, square root 4, and then you divide each one by 2. And then for cosine, you do the opposite of the sine. So root 4 on 2, root 3 on 2, root 2 on 2, root 1 and 2, root 0 on 2. Just the other way of the sine. And so let's go sine 0 is root 0 and 2, which give you 0. Sine pi and 6, root 1 and 2, which is 1 and 2. Root 1 is just 1. And sine pi and 4 is root 2 and 2. Sine pi and 3 is root 3 on 2. Sine pi and 2 is root 4, which is 2 on 2, which is equal to 1. And so therefore cos 0 will be 1 as well, root 4 on 2. And cos pi and 6, root 3 on 2. Cos pi and 4 is root 2 on 2. Cos pi and 3 is root 1 and 2, which is just 1 and 2. And cos pi and 2 is 0. So for tangent, you just take sine over cos. So 0 over 1 will be 0, and then half over root 3 on 2, that will be just 1 on root 3, or you can say root 3 on 3. That's tangent of pi on 6. Tangent pi on 4, you take these values, root 2 on 2 divided by root 2 on 2, which give you 1. And tangent pi on 3, you take that root 3 on 2 divided by 1 and 2, which give you root 3. And then tangent pi on 2, which give you undefined, because it's 1 divided by 0. Okay. So let's do this in one big table summary. You might like to pause and work on this table, maybe come back and check your answer. Remember that your sine is a y, cos is x, and the tangent is basically y over x. So use this unit circle to help you for the corner angle. So you got 1, 0. So sine of 0, which is the y coordinate, is going to give you 0. Cos of 0 is 1, because that's the x coordinates. And then tangent is basically 0 over 1, which is 0. Whenever sine 0, tangent will be 0. And then pi over 2 is that corner. So we have y value of that is 1. So sine pi and 2 is 1. Cos pi and 2 is 0. The x coordinate here is 0. And the tangent will be undefined. Whenever the cos is 0, tangent will be undefined. I'm just going to put DEF, undefined. So sine pi, which is this quadrant, the y coordinate again is 0, the x coordinate is -1, and the tangent will be 0 because 0 over 1, and 3 pi over 2, which come back to that corner. The sine of 3 pi and 2 is -1, cos of 3 pi and 2 is 0. You notice that whenever I deal with pi and 2, 3 pi and 2, the cosine will always be 0. And the tangent will be undefined. Okay, now 2 pi, sine 2 pi is 0, cos of 2 pi is 1, and tangent will be again 0 because 0 over 1. The pi 6, pi 3, pi 4, it will be good to use the special angle. I'm going to put pi with 6 here, 30 degree. So immediately I put 1 here, 2 here, and root 3 here. That's the hypotenuse. So sine pi over 6 is opposite over hypotenuse. Remember this well. Just remember sine pi on 6. Sine pi on 6 is half. Sine pi on 6 is half. 1 over 2. And so therefore cos pi on 6 will be root 3 over 2. And tangent pi on 6 will be just 1 over root 3, or root 3 on 3. Okay, now that's pi over 3. That's pi over 3. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. So cos pi on 3 is 1 on 2. Tangent pi on 3, which is opposite, is root 3 here, and adjacent is 1, so which give you pi on 3. And pi on 4 is, remember, the isosceles triangle. Pi over 4, that pi on 4, so therefore is 1, 1, and root 2. So 1 on root 2, which is root 2 on 2, root 2 on 2, which is the same as 1 on root 2. And then tangent pi on 4 is 1. Okay. For each of the following, determine the sine t cos t. Okay, what is sine 0? Quickly, what's sine 0? I can hear some of you say sine 0 is 0. What's cos 0? cos 0 is 1. So remember that's cos 0 here, the x coordinate. 3 pi and 2, think of which part, which quadrant is in here. So cos 3 pi and 2. What is cos 3 pi and 2? Cos 3 pi and 2 is 0. Sine 3 pi and 2 will be negative 1. Negative 5 pi and 2, you're going to opposite directions. So if we go to one round, it's negative 2 pi, negative 5 pi and 2 is at that corner. So think of what is a sine cos. So I want you to finish the rest and then maybe check with me the next round we come together, or check with your friends in this question in these questions. All right. Next one, find the exact value of cos 180. So step 1, locate on the unit circle. Where is on a unit circle? 180 degree, which is here. So cos is the x coordinates. So it's negative 1. Cos of 180 degree is negative 1. The x coordinate at point P, and it's negative 1. Easy. Okay, now let's look at quadrant 1 angles. The x is a cos theta, the y is sine theta. So let's write this as cos theta, sine theta. And that's a quadrant 1. Okay, so in quadrant 1, your x is positive, y is positive. In quadrant 2, cos theta positive, sine theta positive. I'm blocking that, so I'm going to erase this. Cos theta is positive and sine theta is positive because x and y are positive. And the first quadrant, and therefore tangent also has to be positive because tangent is simply just sine over cos. In the second quadrant, x is negative, y is negative. These are all the negative x value on these quadrants, and the y is positive. So these are all the x and y coordinates. Okay, so which give you cosine is negative and the sine is positive. Tangent will be negative because positive over negative numbers. And in the third quadrant, x is negative, y has to be negative. Please do a corrections in your note, please. It has to be y less than 0. So which give you cos is negative, sine is also negative, tangent will be positive, negative over negative. In a quadrant 4, you got x positive, y negative, and so tangent will be negative as well. So basically x is positive in the first and the fourth quadrant. Y is positive in the first and the second quadrant. Okay, summary. All positive in the first quadrant, only sine is positive in the second quadrant, only tangent positive, and the cosine is positive. Some people like to use ASTC. Some say all stations to central. Some say all students talk crap. I believe so. All right, let's now go into detail of second quadrant. So first quadrant, we say theta. The second quadrant, so you measure from here to here, that will be pi minus theta, or 180 degree minus whatever the angle is from here to here. So I want to find out what is this y coordinate. Sine of pi minus theta, that y coordinate is exactly the same as y coordinate on that side. So I can say that sine pi minus theta is the same as sine theta. And cos of pi minus theta, this x coordinate is the negative of the x coordinate on the first quadrant. So I can say cos pi minus theta is negative cos theta. Okay, let's move on to the third quadrant. So in the third quadrant, we will say pi plus theta. So let's read the angle is pi plus the theta. The y coordinate is called the sine of pi plus theta, and the x coordinate is cos of pi plus theta. And the sine of that is the negative of the first quadrant answer, and the cosine of pi plus theta is also negative of the first quadrant answer. And the fourth quadrant is what we call the 2 pi minus theta quadrant. So 2 pi is 180 degree minus theta, so it's come back to here. So the y coordinate is read as sine of 2 pi minus theta, and the y coordinate is read as cos of 2 pi. Sorry, the x coordinate is read as cos of 2 pi minus theta, and y is sine 2 pi minus theta. So tangent is basically just sine over cos, and tangent is basically the distance from here to here. I hope you can see my drawing. That's tangent 2 pi minus theta. And from here to here is tangent of theta. Okay, all right. Next, let's focus on each one of them. So, first quadrant, the coordinate is called cos theta, sine theta. Let's say this is A, and that's y coordinate is B. So on this side, that will be minus A here, and the y coordinate is still B. So sine of pi minus theta is the y coordinate is B. So therefore, that equal to sine theta. So sine of pi minus theta is the same as sine theta. Cosine of pi minus theta is negative A. So therefore, negative cos theta. Tangent is basically just sine over cos, which give you B over negative A. So we'll give you negative tangent theta. In quadrant 3, you got sine pi plus theta. So that's pi plus theta, and it gives you negative sine theta. That y coordinate is a negative of that sine theta. Okay, so that in terms of magnitude, they are the same, but it's just the opposite sign. So cos of pi plus theta is negative cos theta, because that and that are the same value, but it's a negative sign because this is on the negative side. Tangent is basically sine over cos, and fourth quadrant is sine 2 pi minus theta, 2 pi minus theta quadrant, fourth quadrant. In terms of the angle is 2 pi minus theta, so the y coordinate sine 2 pi minus theta is negative sine theta, because that is negative. And the x coordinate is cos of 2 pi minus theta, which is cos theta, and the tangent is just negative b on a, so which give you negative tangent theta, a sine cos. So these relationships are true for all values of theta. All right, now let's look at the negative angles. So what is sine of negative theta? Basically, negative theta is in the fourth quadrant. So sine negative theta, which is here, and we know that that is just negative y, so it's negative of sine theta. Cos of negative theta, which is that value, which is the same as the x value, which is a cos theta. So you notice that sine is an odd function. It's like f of negative x is equal to negative fx. That's the odd functions. Cosine is an even function. Tangent is also an odd function. Tangent of negative theta is the same as negative of tangent theta. And shall we look at example 3? Let's evaluate this. What is cos of negative pi over 6? So cos, that's in the fourth quadrant. Cos is positive. It's the same as cos of pi over 6, and also we think of it as even functions. And cos pi and 6 is root 3 over 2. Again, whenever you forget, remember the special triangle. If I put 30 degree here, which is pi over 6, I put 1 immediately here. The opposite of the 90-degree is always 2, and therefore the remaining will be root 3. So cos of pi 6 is opposite over hypotenuse. Oh, sorry. That's sine. Cos of pi 6 is adjacent over hypotenuse root 3 and 2. That's correct. Sine of pi over 3. So pi over 3, that should be your pi over 3. That should be 60 degree, pi over 3. Sine opposite over hypotenuse. But because this is in a fourth quadrant, sine is actually negative. This is basically written as sine of negative pi over 3. That's the same as, oh, we already wrote here. All right, tangent pi over 4 is negative tangent pi over 4, using that concept. Or understanding which quadrant, that's in the fourth quadrant. So tangent pi over 4 is just 1, so it's just negative 1. Okay, did I make any mistake? Cos pi over 6 is root 3 and 2. That's correct. All right. So in general, sine theta is equal to sine theta plus 2 pi. So basically, sine theta, if I add 2 pi, it doesn't change my y coordinate. So sine theta plus 2 pi is the same as sine theta. Cos theta is the same as cos theta plus 2 pi. You come back to the same spot. And tangent theta is the same as tangent pi plus theta. In fact, from the periodic of a singular function, sine theta is in general is equal to sine theta plus 2k pi. For example, if k equal to 1, then you have sine theta plus 2 pi. If k equal to 2, then you have sine 4 pi plus theta. What's sine 4 pi plus theta? Basically just going 2 round and come back to the same space. So same sine theta. Cos 2k pi plus theta is the same as cos theta. Tangent k pi, because tangent, it doesn't go, you don't need to go 2 pi, it's just one cycle, one periodic is pi. From here to here is pi. So tangent theta and tangent pi plus theta is the same. So in general, tangent k pi plus theta is equal to tangent theta for all integers case. Right. Okay, let's pause and have a go with example 4. And once you finish, come back and we shall discuss the solution. So in this, cos 5 pi 4, remember, think of which quadrant. Try to relate with, like, is it pi plus theta, is it pi minus theta, or 2 pi minus theta. So for the first one, cos of 5 pi over 4, I can write as pi plus pi over 4, because I can say that this is 4 pi plus pi. That's how you write your 5 pi over 4. So 4 pi over 4, that will give you pi. So cos pi plus pi over 4, immediately you recognize that it is in the third quadrant. And in the third quadrant, cosine is negative. It's a negative of cos pi over 4. That is pi over 4. Okay, and cos pi over 4 is 1 and root 2. So negative cos pi over 4 will be negative 1 and root 2, or negative root 2 on 2. All right, sine 11 pi on 6, I can write as 2 pi minus pi and 6, because I can say 11 pi is 12 pi minus pi. 12 pi over 6 is 2 pi, so it's 2 pi minus, which immediately help us to recognize that it is actually in quadrant 4. In quadrant 4, sine is negative, so it's negative of sine pi and 6, which give you negative half. Sine pi and 6 is half. So you got to remember that exact value. Sine pi and 6 is half. Sine pi and 6 is half. Cosine 203, think of the biggest number that 3 can go into. I'm thinking of 198. So 198 divided by 3 is 66. So it's 66 pi. So you still have 2 pi left. So that immediately helps you to see 66 pi. Every time when you go to even pi, it comes back to this quadrant, like 2 pi, 4 pi, 6 pi. And now you just add 2 pi and 3, which give you quadrant 2. So immediately you will know that that is, if this is, so that will be equal to cos 2 pi and 3. And of course, you can also say cos of, it's the same as negative cos pi because that is in the second quadrant. Second quadrant cosine is negative. It is, you can say that 2 pi and 3 you can write as pi minus pi and 3, which help you to see that it is negative cos pi with 3. That's pi with 3 here. I'm going to write it here. Okay, cosine is negative. So cos pi and 3 is half, so it's negative half here. Tangent 52 and 6, think of a biggest number where 6 can go into. I'm thinking of 48. So 52 is 48 plus 4. 48 pi and 6 will give you 8 pi. And then I got 4 pi and 6, which is reduced to 2 pi and 3. So again, you think of 8 pi here, so plus 2 pi and 3. Back to second quadrant. So the acute angle on that side, that is pi over 3. So tangent in the second quadrant will be negative. So you'll be thinking of negative tangent pi and 3. Yeah. Or if you go slowly, that tangent 8 pi over 8 pi plus 2 pi and 3 is basically just tangent 2 pi and 3, which can be written as negative tangent pi and 3. And of course, negative tangent pi and 3. What's tangent pi and 3? Tangent pi and 3 is root 3, so it's negative root 3 here. So negative root 3. All right. So let's go to the next. Now, I'd like you to do exercise 6B. As I'm doing, I would like you to stop, pause, and do question 4 and 5, and then come back and check your answer. I'll do question 4 with you, and I want you to do question 5 and the rest as homework. So when you come back, check answer for question 4, and then I'm going to keep question 5 in class. I'll do that in class in a way of revising, use it as a revision. So I'm going to work that psi pi minus theta. Which quadrant would that be? That's in the second quadrant. Psi is positive, so psi theta. It's the second quadrant. That's theta. Psi theta is 0.52. That's what given. And then I look at cos pi plus x. That tells me it's in the third quadrant. So that's x here. So it's a negative cos x, which gives you negative 0.68. That gives you back to the first quadrant because 2 pi plus theta is the same as, sorry, sine of 2 pi plus theta is the same as sine theta, and which is going to give us 0.52. Tangent pi plus alpha is the same as tangent alpha. Okay, the third quadrant. Tangent alpha is 0.4. Sine of negative, that's the negative angle which is in here, which is the same as negative because the y coordinate is negative. It's in the fourth quadrant. Negative sine theta, also think of odd functions. Negative sine, so it's negative 0.52. Now I'm going to stop here. I'm going to let you work on question 5. When I start with you in class, I'm going to go through question 5. You're going to mark your work. So question 5 will be your homework. So as this 10 minutes of work time for the rest. Right, and then question 2, 3, and 4. Again, I'll go through this in class. So, and then finish homework 6A and 6B. Remember to bring your notes to class the following lesson. Bye for now.